Good morning from here, everyone.
Good morning. Happy
Good morning.
Friday.
Hey, Josh. Hello. Hi, Greg.
Hi,
Hey. Hi,
everyone.
Justice.
Hi, good
Hi,
morning.
Jeff. Hi, Shika, Bonnie,
Hi.
Hey,
Morning.
Justice.
Lily, Gabriel, Gerald, Josh, Greg. There's a lot more people in here than I'm used to.
Uh, and I think Ruby is going to join us too, from Paces. She just pinged me.
Fantastic. Excellent. Right.
Hello, everybody.
Hi there, Colin.
Hey, Colin.
Hi, Rajesh. Hello, Emily. Welcome.
I'm going to send Ruby the link real quick, Justin.
No problem. Go ahead. We'll just give everybody a couple of minutes. I got some feedback from somewhere. Hello, Matt. Hello, Arif.
Hello, hello.
Hi, Joseph. Hello, everyone.
Hello, Sean. I see you there.
Injustice, good to see you.
Hey, Arf, it's Josh. I sent Ruby the link, just FYI.
Yeah,
She was
Ruba's
asking
there.
for it.
Yeah, I'll
Oh, there
put
she
Ruba's
is.
in. Hi, Ruba. Hi, Justina. Akshay.
Hi there.
So maybe just by ways of introduction, we may get a few more people joining as we start. So just to set the scene for everybody who is here already. So this is typically our Tazama Technical Steering Committee meeting slot. Thank you very much for joining. Some of you may also have seen the information that went out on LinkedIn over the last week. So thank you, Michelle, for that. To promote a slight change in our agenda for today, not to depart from matters of the TSC, but more specifically to showcase some of the work that had been done on behalf of Tazama under a grant that we had pursued and been granted, I guess, earlier in the year with Delta Analytics as part of the Data for Good in 2026. And we wanted to show the work that we had done with the team, and in particular, the team who is here is going to be showcasing that work specifically. And if I can find my screen controls, Zoom, thank you very much. That would be great. Here we go. Right. All right. So we're going to take you through a little bit about the work itself, set the scene, and because this is also going to go out as part of Delta Analytics' internal showcase, for the work that they are doing with their stakeholders. We're going to do a introductory setting of the scene, go over some of the information that people from our Tazama community might already be familiar with, but would then serve as an introduction into the work that Delta Analytics did so that they could carry this presentation into their own media as well. So welcome everyone to the Technical Steering Committee meeting for Tazama. Tazama is an open source real-time transaction monitoring system. Our mission is to build trust in financial instant payments ecosystems, and in particular to protect those who need it the most, financially excluded, who are now entering the digital economy, perhaps for the first time. We are aiming to make those transactions for those people as safe and secure as possible by protecting them from fraud. That trust is critical to promote the ongoing health and sustainability of financial inclusion ecosystems, instant payments systems. People who have a bad experience with fraud, when they immediately join a system like that, are immediately discouraged from continuing to use it. And we would like to avoid people using cash. Digital finances are inherently safer and also more accessible and interoperable. This is a little bit about our journey to date. We started as an idea as part of the Level 1 project principles, was coined by the Gates Foundation. The Gates Foundation called for a interoperable financial transaction switching environment, but also a shared investment in fraud infrastructure. From that initial idea, the Gates Foundation approached Deloitte in South Africa to draft a requirement specification and to do a study of fraud and money laundering typologies that impacted inclusive instant payments systems. And from there, that resulted in eventually the build of Tazama, which was focused largely on providing safety and security for switching transactions in Mojaloop, the sister project that the Gates Foundation also funds. In 2022, we delivered our minimum viable product and went live with an engine that contained 30 rules and typologies. That was delivered to the Mojaloop community itself. And then we soon realized when we started doing our beta testing, working with a number of potential adopters of the system, we soon realized that the system had the potential to provide a safe and secure transacting environment beyond just switches and beyond just Mojaloop. So the Gates Foundation donated Tazama to the Linux Foundation, which now provides all the governance and infrastructure that we require to operate as an open source project. Under the Linux Foundation, we released our second version of Tazama in 2024. We joined the Digital Public Goods Alliance in 2024 in September, which also then gives us access to the scope of the digital public goods and digital public infrastructure under the UNODC. We went live at the time in 2025 in March for 3 customers, released our version 3 in November last year, and to date we have 6 live customers and there are about 40 customers on the way. So Tazama is growing and we are well positioned to make a difference in the world. So thank you very much also to Delta Analytics for joining this effort in helping us change the world for the better. And we are looking forward to Tazama Release 4, which is coming soon. The work that Delta Analytics did for us here will also be part of the Release 4. So you can look forward to seeing the output of today's session in our Release 4 implementation as well. As I mentioned already, Tazama is aligned with financial inclusion goals. So where people are being encouraged to enter the digital economy through better access to services, wallet services, mobile money services, more your fintech and non-traditional banking services, interoperated through something like a Mojaloop switch, Tazama is ready to provide the safety and security of those transactions in those ecosystems. We're also built to comply with regulatory standards, to protect data, to make sure that the transactions themselves are in a standard ISO 20022 format, and to provide transparent and open reporting for regulators and compliance officers and auditors. Our value largely is as to make a ethical and social impact across the world. We partner with a variety of institutions. We also spend quite a lot of our time pursuing like-minded partnerships and organizations who would help us to grow our availability and our accessibility across the world. As we'd already mentioned, we are currently funded by the Gates Foundation. We are actively also pursuing funding beyond the Gates Foundation, so if anybody's interested, please do call us. We are governed by the Linux Foundation that provides all of the open source infrastructure and governance that we require as an open source project. What differentiates Tazama from the other products in the market? Aside from the fact that we are a free and open source technology, Tazama offers a real-time transaction monitoring. It is an essential component of the system. Given the speed at which fraud is evolving and taking place, Tazama has to be able to interrupt a transaction in flight. A transaction that is allowed to complete results in an almost assured loss to the customer, reputational loss to the institutions, reputational loss, and a lack of trust in the digital ecosystem in which that transaction is facilitated. Money that is lost in an instant payments environment is almost never recovered. So for us, the objective here is to be able to stop that transaction from happening if that transaction is suspicious. It is integration ready. We provide an ISO 20022 interface out of the box, and we have also now with release 4, we'll be introducing additional tooling to be able to allow you to configure your own interfaces through configuration rather than as a hard-coded exercise. Scalable from small volumes to exceptionally high volumes, up to 2,800 evaluations per second. Customizable and configurable rules. All of the rules that we start with in the system, the 33 that we already have, you will also have access to be able to tweak them and adapt them to changing trends in the fraud behaviors, and also to be able to add to those rules as you discover additional behaviors in the system. Is compliance friendly in particular? We always aimed to deliver explainable results. So a rules-based system lends itself a little bit more towards that. The results themselves are transparent and not opaque. And this is in particular an area where we are very excited about this collaboration, because the work that Delta Analytics has done for us is to be able to improve that explainability and transparency to an unprecedented degree. And the thing that really sets us apart is you can start your fraud detection journey with rules today, and you can transition them to AI tomorrow with the same rules without having to make any other changes in the system. You just add labeled data to train those rules as the only thing that needs to happen, and you can do that in the same system with exactly the same infrastructure. A little bit about where we are going. I don't want to dwell on this too much, but this is where Tazama 3.0 is currently covering. It's a number of interfaces, getting those transactions into a core engine. The engine does the evaluation. So immediately when we took this to customers, they said, where can we see the alerts that is coming out of the system? Because we don't have a case management system of our own. So that encouraged us to then build the rest of the ecosystem here, which now includes case management functionality. And in particular of interest today is the reporting in the business intelligence, analytics, and reporting area, which is structured around Jupyter Labs, where we can create notebooks that can then interact with data that is sourced from both the Tazama engine and the case management system itself. I'm going to hand over to the Delta Analytics Data for Good team, and then you can take it from there. I'll stop sharing and I'll pick it up again later. Thank you very much, and good luck.
Hello, everyone. This is Jeff Gunderson from Delta Analytics. Good morning, good afternoon. Are you seeing my slides?
Yes, I can see them. Thank you, Jeff.
Wonderful. Thank you so much, Justice. So today, we're going to be, oh, sorry. Let me grab that. So today we're going to be covering Delta's mission, give you some background on that. We're going to be talking about the fraud investigation BI solution, business intelligence solution. And we're also going to be covering the conversational agent for fraud analytics, or fraud investigation. So we'll also have some time at the end for questions and answers. So if you have any, just use the chat and we'll queue those up for later. Some background on Delta. So Delta was started 13 years ago by a group of data scientists who wanted to leverage data for good. Delta's mission is to help nonprofits with the skill gaps that many face and to use their data for social impact. Since 2013, we've completed over 80 projects with nonprofits. To staff the Data for Good projects, we recruited over 300 volunteers, and we have given over 28,000 hours of time, all without charge. We have also curated an open source curriculum on analytics and data science. So what I'd like to do is turn this over to the teams that develop the solutions. First, we're going to be covering the BI solution, and I'm going to turn this over to Shika Pamnani to talk about the solution.
Hi, good morning. Am I audible?
Yes.
Okay, great. So, hi, I'm Shikha. I'm an analytics professional with expertise in digital payments and financial inclusion across India and United States. I'm the project owner for the Tazama Data Visualization Project via the Delta Analytics Fellowship. I am very excited to be here. Thank you for this opportunity to present in front of the community, the Gates Foundation, the Linux Foundation, and the financial service partners. Before I give you a brief introduction of our project, I would like to introduce my team. We have Rajesh, the data architect. We have Emily, the economic researcher, and Husandeep, financial analyst. This is my team, and we have worked on this project from last 4 months. Now give you an introduction of the project. We have been working on these 2 interconnected data visualizations, primarily for the investigators, to make their life more easy and make them move beyond the alerts. So when Tazama came to us, this picture was a little hazy, but we took this project and we constructed and we developed this so that we can help investigators to dig deep down into the alerts, so that they can see why the alert is being raised, why this rule is being triggered, what is the data connected to it. And they can not just see an alert, a binary word that is alert, but can convert the raw alert into investigative intelligence. Yeah, we can move to the next slide, Jeff. So there are 2 visualizations that we developed here. One is the alert navigator, which gives you everything about the alert, the metadata about the alert. Another is the rule trigger discovery, which gives you a detailed analysis of why the rule has been triggered with all the data behind it. Next slide, Jeff. Okay, can we move to the previous slide? So we have discussed what is Tazama, and Justice has given an amazing introduction of what Tazama is doing. I would just like to call out here that Gates Foundation has very strategically funded the 3rd pillar of the level 1 project and a very crucial element for the digital public infrastructure. And it's not a standalone tool, but it's something which is combined with the rest of the 2 projects that they have funded, and to help the financial service providers to build a digital public good. So it's real time, it's customizable, like Justice told, and it's basically targeting the emerging markets, which are actually exploding with the growth in the adoption of digital payments. And when the digital payments rises, the fraud also rises. So Tazama is very strategically positioned as a fraud protection layer. Okay, let's move on to the next slide. I'll ask Emily to take over from here. Emily, over to you.
Thank you, Shika. So we've already kind of talked about now what Tazama does, and Shika has mentioned a bit about kind of what our team has been brought in to do. But just to kind of bring that point home, so when a transaction happens, we know that Tazama is running through about 33 rules and 31 typologies in real time. So it's evaluating things like, how old is this account? How recently did it transact? Is the amount unusual? And each of these rules produce a score. That score gets weighted and combined with other rules. And if the total crosses a threshold, an alert is fired and that lands on a fraud investigator's desk. But the issue, as Shika kind of mentioned, is that the investigators are really just seeing one thing, and that's a word that says alert. So they don't really know exactly off the bat which rules are being fired or the scores or the specific transactions involved that seem suspicious. None of that is really easily visible to the investigator. And so that means that every investigation has to start from scratch, manually digging through transaction histories, trying to reverse engineer why Tazama's system has flagged something in the first place. And so that kind of is where we come in, right? Tazama had built a world-class detection engine, but investigators don't have a great window into it. And without that explainability, even a powerful fraud detection tool loses a lot of its investigative value. So that's the gap that we were being asked to close as the BI team. Next slide, please.
We'll
Shika,
move on
you're
to
on
the
mute.
solution. We'll move on to the solution. I think that's presented by Hussein. Hussein will take that.
Can we move back one slide, please?
Yeah.
Yeah. So as Emily mentioned, in the previous scenario, the investigator doesn't have all this information and has to manually dig through why a specific transaction was alerted. They have to go through all the transactions and see, what led to what typologies were triggered or what rules were triggered that led to the transaction being alerted. And the visualization that we've been working on for the past few months provides all of this information to them. So there's a few parts to this visualization. It starts with the alert navigator that allows the investigator to filter the transactions by the tenant, the amount, and then they're able to select a specific transaction. And then they're able to dig deeper into the next part of the visualization, which is all of the 31 typologies that were evaluated, see the score of that typology, the thresholds, and whether or not it was breached. So what the typology is basically a numbered configuration that groups all of these rules to define a specific fraud scenario. And then if you scroll further down in the visualization, they can then see all of the rules that were evaluated as well. So the 33 rules, it then tells you the weight of the rule, the specific independent variable that is calculated specific for this transaction, and then a reason. And then if you want to look further down and see more information regarding these rules, there's also the rule discovery portion of this visualization that allows you to find more information. For example, let's say if you want to look into the rule that determines the creditor account age, once you click on that rule in the rule discovery, it even provides you the oldest transaction from that creditor account. And that's just one of the rules. Now Shika will give us a demo and we can look into even more rules and the type of information that you can look at in this visualization.
Okay, Jeff, we can move on and I can probably share the solution. Jeff, you'll have to stop sharing so that I can share the screen.
Okay.
Um, uh,
Have
the
you got it yet?
presentation, no, I haven't. You're still sharing the screen, so
Oh,
you'll have
yeah,
to kind of,
sorry.
yeah,
Okay.
stop sharing the
Let me
screen.
stop
Yeah,
sharing that. Okay.
yeah. It is still being shared. No.
Yeah, sorry, it's having trouble removing it from the share. Just a second.
Do you have the presenter permissions? Maybe
I'm
that's
not
why you're
sure.
unable to override the sharing of the screen.
Yeah, and unfortunately, this meeting is being set up out of the Linux Foundation's orchestrator, so I don't know that we have the authority inside the session to change anything.
Oh, okay.
Jeff, if I may make a suggestion, the one way to do this is perhaps to rejoin the meeting.
Oh, okay. Rejoin the meeting.
If
Okay, so I will
yeah,
drop out and Shika, you can take
yeah,
it from there. Okay.
it's the
Okay.
only way I can think of at short notice. Sorry.
Okay.
Okay.
Oh, there we
I
go.
will
It's stop
just,
sharing. I think
yeah.
you're okay now.
Okay. Okay.
Okay, more screens. Motion browser tabs. Notebook. Tabs. I am trying to look for tabs. Okay. Screens. Found. I'm actually not able to find that browser tab where I can share more.
Oh, are you looking for the share button?
I did look out for the share button. It's not giving me an option to share the browser tabs actually.
Okay. Well, you can share your entire screen or your windows.
Mhm.
It's
Yeah,
not
that's what I'm
giving you the
looking.
option. Okay.
Yeah, it's here. Okay, is it visible?
Yes, it's coming. There we go.
Okay.
Awesome.
So we will, it's a very huge code. So I will move directly, scroll down to show you what exactly the visualization looks like. Okay, so there are two parts to the visualization, and I'll start with the alert navigator. The alert navigator will let you assess all the data behind an alert. So the investigator will start with this drop down and they will select an alert. I've already selected an alert over here. The tenant is Tazama. So how do you identify an alert? You identify an alert by the tenant name, the alert, ALRT, the alert has been raised for this transaction, the date of the transaction, the amount that is transacted, and the evaluation ID. When you select any of the alerts, you will have the alert metadata. Let me select a different alert to show you what exactly is happening here. Okay, select this one. Okay. So you see the alert metadata comes right here where you can assess what is the data that is connected to an alert, including what is the transaction status, the amount that is transacted, the number of typologies that are evaluated. Now, there is one very interesting parameter here, which is the EFRUP, which is the external fraud universal processor, which basically tells you if there's an external indicator connected to this transaction or this tenant or not. Now, there are three options to this parameter. It could be overridden, it could be block, or it could be none. None means that the evaluation, like the typologies and the rules, will be evaluated in a normal way. If it is overridden or blocked, which means that this entity has a previous external indicator as a fraudster or a fraudulent transaction already. So without evaluating the typologies and the rules, the transaction will be overridden or blocked. That means none of the further process is valuable anymore and they will be straight away blocked. The next part gives you the typologies evaluated. It basically shows you a table which shows what are the typologies that were evaluated, shows you the typology score with each and every typology, and compares it with the alert threshold and the interdiction threshold. Now, if it is more than the alert threshold, that means an alert will be raised. If it is more than the interdiction threshold, that means the transaction will be straightway blocked. There's also this parameter which tells you whether the typology has been breached or not. If you see the typology score here is 700, equivalent to an alert threshold, that means the alert will be raised and the typology has been triggered over here and has been breached. Rest of the other typologies have not been breached, so there's no alert has been raised. Let me select one of the alert which shows more than one typology has been breached here. And if you see, there are two typologies that have been breached here, and each typology is basically a fraud scenario which has a bunch of rules triggered. So there's two typologies, so there will be different set of rules that will be triggered for each and every typology. As we scroll down, we have the rules that have been triggered in these typologies. So in this visualization, we have implemented 15 rules, even though Tazama has 33 rules currently being triggered. As a POC, we have implemented 15 rules. And with every rule that we have implemented, you can see there is a description that is attached to a rule identification. So wherever you find a description attached to a rule identification number, that means this rule has been implemented. If you just find the number or the rule identifier here, but with no description, that means that rule is not implemented in this visualization and it wasn't a part of the POC. Even though it is evaluated, it will not be a part of the data visualization. It's not a part of the POC. We will only have the rules with the description that you will found in the drop-down box later. Okay, so moving on, I'll just quickly explain what this table basically shows. It gives you the name of the rule that has been evaluated. Each rule has a weight connected to it. So whenever that rule is triggered, we have the weight being displayed here. Each rule also returns an independent variable. Now, this independent variable could be the number of transactions, could be the transaction type, could be the creditor age, could be the debtor account age, which is connected, which is the return variable for a rule. So here the independent variable is 1. Now, sub-rule reference basically gives you the band in which this independent variable is falling, because each rule gives you an independent variable which falls in the severity. The band basically tells you where this independent variable falls down. We'll see that below, where you'll get more details in the rule discovery visualization. So here the sub-rule reference is 0.1, and it also gives you the reason why this rule has been fired. First successful payment from this debtor to the credit account. The first successful payments are always suspicious if it is a new account or it is the first payment. Similarly, this is rule 045, creditor lifetime transaction count with a weight of 200 and a sub-rule reference of 0.02. One successful payment has been made to the creditor account. Similarly, there are all the rules with the description that have been evaluated and have a weight attached to this one. Only the rules which have the weight attached to it are the ones that are triggered and have an independent variable. For example, if you see rule 078 has a transaction type, which is a mobile person-to-person payment. Okay, so this is the rule table, and we will move on to the rule discovery and we'll dig down more deeper into it. So I'll just select a transfer to unfamiliar creditor. This is the rule which I want to see and what is the data behind it. If you see, it will give you a description of what this rule actually does, which basically transfer to unfamiliar creditor account. That means they are sending amount to a new creditor. It counts a confirmed successful transaction between this specific creditor-debtor pair to the alert date. The independent variable is that they just found one transaction. Now we come to the bands. Now these are the bands, and you'll have to see where this independent variable is falling. This independent variable will fall down in band 1, which is the first successful payment from this debtor to creditor account, because the lower limit is none, but the upper limit is 2. So it falls in band 1. And you can also see the transaction metadata that is connected to it, which is the debtor account ID, creditor ID, the date time, the transaction type, transaction status, amount, and so on and so forth. I will request Hussein to please demo the other rules, and we can take it from there.
Thank you, Shika. Can we click on the rule? And
Yeah.
let's select the age classification of the debtor.
Yeah. So we'll run this one now.
Okay. So as you can see, it provides a description of what this role is. So in this case, this is the debtor's age in years. And this is used to flag transactions where it's occurred, where the account is held by someone who's a minor or an elderly customer. And the independent variable lets you know that the debtor's age is 25 years.
Sorry.
And it also provides the birth date. And then in the band thresholds, there are specific limits. And this one falls in band 2, which is then connected to the several reference column, again in the above table. And then it provides more information below on the birth date, the age, as well as the end-to-end ID of this account. And then let's select a different rule. We can do the debtor lifetime transaction count. Okay, so this one shows all the successful transactions from this debtor, including this transaction that was alerted. So from this debtor, there was one transaction found, and that falls in band 1. And so it just displays that one transaction below. But if this debtor had, let's say, like 11 or 20 transactions, all of those transactions would be displayed below. So for the investigator, this would really make it easier to see why the specific rule was triggered.
Hussein, let me select another alert which shows you the rule 16 and 17,
Okay.
which has more, transactional history. Let me search if we can find that alert. No. Yeah. The rule triggered. Yeah, we have that kind of. No, we're not getting that rule being triggered here. Let me select something from the 15th. 48. Okay, so yeah, it's still running. Do we have, yeah, we have 16 and 17 here. So now you can show the rule number 16. Let's showcase rule number 17, which is the data conversions. Yeah, go ahead.
Okay. So rule 17 shows all successful transactions from the debtor within the 8-hour time window. So for this one, as you can see, there were 9 transactions found, and that falls in band 2 because it exceeds the lower limit of 5 transactions. And if you scroll down, you can then go through all the 9 transactions that were found and find information such as the amounts as well as the time and date of those transactions and the end-to-end IDs.
Then we similarly have the creditor transaction convergence.
And that goes through the rolling 24-hour time window. And then it has the same lower and upper limits. And in this case, 9 transactions were also found. And then you can also go through those 9 transactions and find more information.
Okay.
Can we also go through, if you can click on the rules, we
Yeah.
can go through the creditor account age?
Yeah, let's do it.
Okay, so this provides information on how old the creditor's account is. So a very young account could mean a newly created or synthetic creditor account. In this case, it lets you know that the creditor account is 23 days old, which falls in band 2. And then this reason that is displaying in band 2 is also provided in the above table in the reason. And then it also provides you the oldest transaction from this creditor account, the date of the transaction as well as the amount.
Yeah. I guess, yeah, these are the rules that we wanted to showcase. This one is 078 transaction type. Yeah.
This transaction, as Shika mentioned before, lets you know the type of the transaction. For example, this one is the peer-to-peer transaction, which falls in band 3. And then it provides more information regarding the transaction below.
Yeah. Thank you, Hussein. So that's all for the demo today for these two visualizations. Please let us know if you have any questions. We would be happy to answer. And if not, we can move ahead with the rest of the slides that are left. I will stop sharing. Okay.
Thank you,
Yeah.
Shika.
Jeff, you
would you
can go
mind?
ahead. Yeah, go
Okay.
ahead and share the
Hey, Shiga, can I
slides.
ask a quick question, if that's okay?
Yeah. Yeah, please.
So, from your transactions perspective, right? Like how far you're going behind? I mean, like whenever that alert rule is getting generated, I mean, the transactions, like it's displaying certain amount of like last 10, 20, or 30 transactions, right? So, what is the age that
Uh,
you are trying to capture in that?
So I guess it is dependent on the rule that we are, the rule that is being triggered. One of the rules says 8-hour window time. So whatever transactions that are there in those 8 hours before the alert is generated, it will give you those many transactions. Now it could be in hundreds, it could be just 2, or it could be just 5. Similarly, there's a 24-hour window. That is, it's basically the time frame rather than the number of transactions that go back in history. Justice, do you have inputs on that?
No, that's exactly right. And that's the real value for us here is if an investigator is getting a alert that the rule had triggered, they can only see the number of transactions, for example, in the set. Um, they don't know which transactions are in the set, who are the people who are involved. So this gives them an introduction to replay exactly the same information that was used to trigger the rule in the first place. And that for us is like the real power of that visualization is an investigator doesn't have to guess why the rule triggered. They can actually see the data itself.
Yeah. I see Matt raising his hand.
Thank you. This is great and really appreciate the contribution. I'm curious on the data that the investigator has access to. Is that limited to the data that's in the Tazama system, or can that UI be used to connect to sort of other data stores at that financial institution that they could then sort of add to that same user interface and allow them to have a richer picture of that account.
I guess that's
Yeah.
also a question for me.
Yeah, go ahead.
So the data in the data lakehouse is compiled out of a number of different sources, predominantly the same data that Tazama ingests for the evaluation purposes in the first place. So all of the rules at the moment focus on that ingested data within the context of the transaction history that was also ingested. But with Tazama Release 4, we are also adding a data enrichment pipeline so that you can add additional data to the system, which will then also end up in the data lakehouse. And then the investigation data that you are accumulating during the case management will also end up in the data lakehouse. So the report that we have here provides a great foundation that we can then extend to also include additional data sources. This functionality currently lives inside Jupyter Lab, but we would want to expose this inside the case management system. We've already built the infrastructure to be able to expose the notebooks from Jupyter Lab inside the case management system through Voila. So this will also live there and then also be able to, in the long run, add additional sort of drill down or contextual functionality to that. So if the transaction is showing up and then you want to be able to explore more information or the enriched data related to that transaction and so on, you can now do that from this platform, from this foundation.
Cool. All right. Thank you.
I think there is one more question in the chat, probably from Bernard. So they're asking, like, how are you planning to seamlessly integrate Tazama scoring engine with Alert Navigator? I don't know if that was answered, but
I think I touched on that maybe a little bit, but just to give a little bit more detail around that. So the Jupyter Notebook itself will be published inside the case management system. So when the alert is generated and turned into a case, the investigator of that case will be able to access this visualization to help him analyze and investigate that particular alert in that case. So the integration is going to be in the case management system. See, Colin, you also have a question?
Yeah. Yes, thank you. Hi, Justice. Good evening, everybody. Mine is around the account age threshold, if I'm mentioning it correctly. Is that configurable? For an example, are we able to define what constitutes a new account, e.g. maybe 30, 60, 90 days? Is that configurable?
Yes, that's configurable. So the entire loop out that we will have now is you will the data itself will be generated as, or the transaction will generate an alert, which then gets investigated with the visualization. And then when the models are updated as your system learns and evolves, you will then refine those values to be more in line with your specific environment. So the configuration data, the bands that you saw when Shika was demoing, those are configurable, so you can set those categories.
Thank you.
I think Greg has raised a question over here in the chat. Yeah.
Yeah, so the JSON file still goes to the case management system, but the business intelligence, analytics, and reporting module that we are building for release 4 will be used to generate the intelligence that somebody will use to do their investigative work. So that's the JSON file is still the mechanism in case somebody wants to be able to connect Tazama to their own case management system. That open interface is still available.
Okay, yeah. If we are done with the questions, we can move ahead with the slides.
Thanks, Jeff. Could you move to the next slide, the impact slide? So I'll just recap this one really quickly because we have really been covering this whole conversation. But so, what Shika and Hussein just demonstrated was that, from an investigator going from just one word with no explanation as to why an alert was triggered, now they have everything, which rules were fired, which typologies matched, the exact weights and behavior attributes that push that score over the threshold. And so that full transaction history replays automatically instead of having to dig through that history manually and kind of reverse engineer the software's decision. So, what used to take digging now takes seconds. And that matters not only because investigators can resolve alerts faster than ever, but it also means that, in a world like we've talked about where new technologies make fraud attempts easier, that fraud is getting caught quicker. The most sensitive populations get protection more quickly, and legitimate users, if they do get blocked, don't get stuck waiting too long for their transaction to get resolved. So all of that is building trust in a world that wants to rely more and more on digital payments. And just like Justice mentioned, this tool is going to be built directly into Tazama's case and investigation management system. So every operator who's going to be running Tazama 4.0 anywhere in the world will have this tool available to their investigators.
Yeah.
Can you hear me?
Rajesh will take this slide, the technical depth.
Can you hear me?
Yes. Rajesh,
Okay,
I can hear
perfect.
you. Just one slide.
Can we go to the technical slide, please?
The next slide?
The previous slide.
No, the
previous
technical
slide.
depth.
Yeah.
Perfect. Thank you. So, remembering the problem from earlier, investigators saw a binary alert and nothing else, right? So everything on this slide exists to close that gap, So on the left side, the visualization draws from 7 tables across 2 layers of the lakehouse. So the alert drop down and the transaction ID comes from the gold evaluation. The rule weights, the independent variables, and the typology scores come from the bronze alerts. So that's the table that answers which rules fired and what the typology score was. The transaction history behind each rule, the replay comes from the gold pad 002 and pad 008 with purpose codes and date of birth filling in the details where the rule 28 depends on. And the band thresholds and the query ranges come from the gold rule. That's what tell you which band the independent variable fell into. And the account identity relationship come from the gold account holder. Every figure an investigator sees on the screen traces back to one of these tables, and nothing is like inferred or nothing is invented. So the stack sits in the middle, the PySpark 3.4.2 against an Apache Puri Lakehouse handles the data layer with the PySpark SQL and JSON parsing to reconstruct the rule logic. And the plotty and the AP widgets, they carry the visualization. This is all inside the Jupyter lab. So this isn't a stack that we picked. It's Tazama's. And the entire BI and reporting layer is Jupyter on Holy Lakehouse, delivered through the YLR. So building inside, it means that no new infrastructure for an operator to stand up, which matters because this ships inside the case management system to every operator running Tazama 4.0. And then there's a column on the right, which is really the story of this project, So the scope for this project was open when we started. We worked with the leadership at both Tazama and Delta Analytics to define a concrete phase 1 deliverable. 15 rules out of the 33 Tazama defines. So that gives us a finish line. And the second one is the sandbox access, which came later than we planned, And basically, it's a simulation sandbox, not a pre-prod or a QA environment. It was never meant to hold production-grade data. Rather than wait, we reset the timeline and we began building against the synthetic data we had. And midway through the project, the data lakehouse migrated and the schema shifted underneath us. So 2 schema changes, 5 weeks through the 8 were done. So the lakehouse was still being built, which we built on it. So we adopted the architecture as it happened and integrated the new evaluation table. And the hardest constraint was the last one. There was no alert test data to build against. So we validated the full pipeline using NALT records and Paces Labs alert data, while Tazama's own alerts were still pending, So not one of these 4 was in the plan, but together they are the reason this tool holds up. And it was built against a data that kept moving, which means it won't break the next time the data moves. Thank you. And next slide.
Okay. Thank you so much, Rajesh, Emily, and Hussein. And I'll just a snapshot of how this journey was for me and my team. We spent around 10 to 12 weeks to build this visualization with a sandbox access, with the synthetic data, with the DLH migration. We implemented 15 rules across 31 typologies. And we had every kind of experience in this project, from data exploration to a DLH migration to defining the project scope and finally testing, documentation, and a final implementation and presenting in front of you today. It has been an amazing journey. Thank you, Tazama. Thank you, Delta Analytics, for giving us the opportunity to work on this. It was an amazing project with immense learning experience, and we are all very glad that we got this opportunity. That's all from our side, and we will move on to the next part of the project, which is the AI fraud clarity. Over to the other team.
Hello, everyone. Can you hear me?
Okay, Yvette.
Okay. Can you hear me?
Yes, Yvette.
Okay, great. Thanks the BI team for taking us through. I guess you've given a lot of context, so I wouldn't go much into that. So first of all, my name is Yvette, Yvette Kondo. I'm the project owner for Fraud Clarity. And Fraud Clarity is a smart Q&A chatbot that helps the analyst quickly understand and get the information that will help them understand why a transaction was flagged as fraudulent. Please, let's move on to the next slide. And I'm very proud of my team because we were able to quickly adapt and because of the change in project scope, we're able to quickly adapt and come up with this smart chatbot. And on my team, I have Lily, who is an internal audit lead at Shopify and has a background in data analytics and international economics. I have Danish, who has a background in business analytics and is a senior data scientist at Domino's Pizza. And then on my team also, I have Danish, who is an AI agent developer intern with a background in business analytics as well. And Fanny, who has a background in information systems and is a principal data and AI solutions architect at CarMax. And then there was also Shashank, who is a senior data scientist at Intuit with a background in analytics. And of course, my humble self, Yvette, who is a senior data scientist with a background in applied statistics. Please let's move on to the next slide. So why did we build Fraud Clarity? So Tazama uses 31 different rules across 31 different categories to detect fraud in transactions. And so when a transaction is flagged as fraudulent, investigators currently have to go through multiple documents to try to understand the characteristics of the account that had the transaction flagged, understand the characteristics of the transactions that was flagged, and try to match up rules to understand why the transaction was flagged. And this makes the investigative process long and also makes it prone to mistakes. But with fraud clarity chatbot, all the analyst will have to do now would just use natural language to converse with the chatbot, and the chatbot will be able to pull out the relevant information from the rules document that it was built on and give them good pointers to make their investigations more effective and efficient. Okay, please let's move on to the next slide. So there are three key things that our Q&A chatbot is built on or has, I would say, the main features of our chatbot. First of all, it uses smart search and retrieval, meaning that when an analyst asks a question, it uses it understands the meaning and the context of the question, matches it up with relevant information on the knowledge base or the rules document that it was built on, uses that to ground the response to augment the response that the LLM or the local language model would provide, and then gives that the relevant information to the analyst. So the analyst is able to get what is most important and relevant to the question that they asked, and also be more relevant to their situation or question that they asked. And then secondly, it prioritizes data privacy, meaning that it makes sure that the information stays within their own local environment, and also has that option where you can use a cloud cloud LLM to be able to retrieve the information at a faster rate, but of course, compromising on data privacy. Then finally, it has an interactive web interface that makes it easy to actually converse, have follow-up questions that can enable the analysts, more like probe further after it provides an answer for them. Okay, so that's really high level, just what the chatbot is about. I'm going to hand over to Fanny to give us how it works. Over to you, Fanny.
Hey guys, good morning. Can you go to the next slide, maybe? Yeah. So, hey guys, good morning. Happy Friday Eve. I think like to put it in a word or two, like this solution is more like a kind of like a logical extension to what Shika's team has developed, right? It's more like where you're trying to report on what kind of alerts are coming in and what kind of solutions that you really want to do. I mean, want to get out of it, whatever that investigator is working on. Whereas with the flawed clarity, the thing that we are trying to do is like extend it, try to see like, hey, why a particular situation has happened if some kind of an alert is generated. Like uh, for example, like Jeff is there, like he got an alert saying that hey, 1995 or 2005, some investigator has solved a problem in a certain way, right? So maybe like the current investigator might not have an inputs or like an vision into like what has been done previously for that particular thing. And this is where the flawed clarity really helps you up with tying up whatever is your old knowledge versus like the current knowledge, and try to kind of like bring them together in a nice massaged way, and try to present the use case to the investigator, saying that hey, someone has already solved this, you just need to add this extension that is relevant to this current time period. So that gives you kind of like a 360 degrees, instead of like an investigator trying to spend on like hey, my alert is received, this is the information that it has provided, what are the different sources of knowledge that I have to really look for. Because in previous presentation, one of the question asked was like hey, can I input my different data source that I really want to look in. I mean, this is where this flat clarity might help you a little bit to get through that the entire 360-degree perspective. So just to walk through, the investigator comes up with a question. It feeds into the chatbot. I mean, if I'm putting in an analogy in motorcycles or anything which I'm very interested in, I would say like every chatbot is kind of like a carburetor. You can just dump everything into it and you're hoping to get an answer out of it. But whereas this flawed clarity is a fuel injector way it does, because we are trying to feed the right amount of data at the right amount of level. That way you are getting that grounded answers and everything that is very much relevant to your use case. So whatever the investigator is asking through, it just routes through that Landgraph conversational memory and everything, and just ties up all those grounding rules and everything together, and kind of like works through those whatever your schematics or vectors that you have stored in your databases, retrieves all those things. And also what it does, the additional thing it does is like it judges the response itself, what how the chatbot is actually respond to it. So that way we really know it's a precise precision answer is being generated to your auditor. And that way you're not really like hey, hallucinating on certain data, or you're not really hallucinating on no, from a model perspective itself also. So that's where your answer comes up with. You have an option to use a judge, or you don't want to use a judge. It really is up to the investigator. That way he has more say on like how he really wants to articulate uh, his questions, or like the way he wants to get his answers all about. So I'll just move to the next slide. Probably I'll have Lily explain you in depth of what the different layers are.
Thank you, Fanny. Hi, everyone. Yeah, I'll just go into the architecture in a little bit more detail, and maybe that'll answer some of the questions. At high level, there's 5 modular layers that you can see here. Starting from the top, the interface that the user sees is a Gradio web app. So that's a Copilot style chat, and it has sidebar for session controls and history. It runs locally, so like we said before, there's a lot of privacy preserving kind of functionality here. But when the user sends a question, it goes into the second layer as a flat clarity chatbot underneath, and that's where the core logic of the chatbot lives. There are 3 main components to it. First, LangGraph that Fanny was talking about. It handles the conversation memory, and it the conversation gets too long over a certain number of messages, like 20 turns, it can condense that and without losing the context, how to summarize the previous parts of the conversation. Then there is a system prompt. This is what keeps the model grounded, making sure it's not gonna speculate, provide unnecessary compliance advice, and they'll just go back to the rule description and try to answer only the relevant questions. And then there is a multi-query retriever. So when you ask about the rule, it's not just doing a semantic search, it's also targeting per rule parts of the document that it's retrieving from to make sure that it pulls the right information. Then there are the three supporting layers below. On the left, the LLM provider, the main functionality uses a local OLAMA model for privacy, but you also have an option to switch to a cloud LLM through API, OpenAI, or Anthropic Claude. Then there is a Chroma DB. That's a vector store that's persisted locally, and it stores the embeddings and then pulls them out at query for retrieval. And on the right, we see the AI judge that Fanny also was talking about. It measures the answer quality. So it scores every response on accuracy, groundness, completeness, and hallucination risk. So we can then tell how well the model actually responded based on the rule document. So at the bottom, you can see that the Tazama rule document that has the descriptions of all the different rules and its components is the primary source of truth for the entire system. We can move on to the next slide now. Thank you. So here's a little bit of, again, specifics on the specific tools and technologies used. Like I said earlier, the main data source is a Tazama rule document, and it can be expanded. So if there's additional information or you want to update the rules, obviously you can feed the new information into the model as well. Then the orchestration layers that handles a lot of the work underneath is based on LangGraph and LangChain, handles the retrieval, message formatting, conversation memory, and so on. And then the local LLM options, the cloud LLM options that they went over, like Yvette was covering earlier, there's some trade-off there between using local LLM for privacy, but in case of hardware limitations, it may be a slower response, while cloud LLM could provide a faster response with a more advanced model, and there are specific system prompts unique designed for each option. Then the vector store is a ChromDB that stores embedded rule chunks and serves them whenever the question is actually being answered. For the interface, like I mentioned, it's Gradio that uses a chat UI with minimal overhead. During the development, everything runs through Jupyter, so the notebooks are the execution environment, which keeps the iteration fast and setup minimal. And for the deployment, there is a Docker file that we share that's lightweight and portable, so the whole thing can be containerized and run anywhere without friction. And now I'll pass it on to Danashri for the live demo. Thank you.
Hi team, my name is Dhanashri. I actually would like to share my screen. Jeff, can you help me with that?
Yes,
Yeah.
share button at the bottom.
Okay. All right. Let me know when you guys can see my chatbot window. Is it up?
It's available.
That's good.
Okay.
Yes.
Okay, all right. So just for the time's sake, I already added some questions so that we don't have to wait for it to generate the answer. But let's get started then. So as Lily had mentioned that we have a Copilot style chatbot interface, and then we have a sidebar. Instead of sidebar, we kind of just have like a drop down where we can have different selections. So as previously mentioned, we currently have option for Olama or Claude model. Right now I'm sticking with the Olama model for this demo. And then we have got options for like, do we want to have a judge assistance or not? That is an option to like have a simpler judge or a stricter judge, I would call it as super judge, or to have both as an option when it generates an answer. Other than that, I have a parameter that says like, make it sure that the answer that you generate has enough evidence in the backend. And there's just a toggle button for show evidence. If I select the judge mode, in that case, this is a relevant option. Other than that, it just has like few conditional things that are set for the chatbot. As an example, I asked it a question like, can you explain me rule 009? So here it says that it used Mistral model and then it kind of generated answer in like 30 seconds. And that was the answer that it generated. If I go to the answer details, it shows me just the details about like how it retrieved, how many chunks it tackled into, and if there is anything else that is associated, it will just provide me depths of that. In this scenario, I did not use the judge mode, so that's why it is like kind of no other details are included in answer details. 1 second. So I tried asking it another question. So I asked it like, when does rule 001 get fired? So it generated answer almost immediately. The moment the question is framed in the words that are kind of matching with the backend documentation, it generates answer almost instantaneously. And I had selected a judge parameter from here, just the simple judge. And I had suggested like I want to have enough depth of evidence for it. When I go to the answer details, it provides me additional information that, as you can see here, overall it gave it 100% score. And the factors that it judged it on was accuracy, groundedness, completeness, and the risk of hallucination. And it additionally provides like the evidence that it looked into to come up with this score. So it points me to like in the backend document, if there are exact reference points, then it will provide me that information here. Let's look at another example. I asked it like slightly different question, like, sorry, this one. Explain me the difference between rule 003 and 001. So in that case, it generated an answer. This time I used judge and super judge both. It took a while for it to generate an answer, but it did generate a good answer. Looking at the judgment score. Sometimes we can see that it takes longer. So first of all, it is a local Olama model, so it can differ, the timing can differ for different people. Also, the model that we are using, we can play around with that. Right now, I'm just using Mistral model, so it could be that as well. We have seen within the team itself, the timing difference is kind of like evident based on the system that they are using. So yeah, as I mentioned, we are using both judge options in this case. And as I previously said, that super judge is like a stricter judge. So the simple judge kind of gave it like 100% score, but super judge, when it generated an answer, like the text that it wrote, it kind of evaluates like how good that written text is. So rule specificity score, it kind of gave 0% score because the wordings are different. It is like not exactly copying and pasting the answer, but overall the answer is correct, so it still gave it a high score. Yeah, and it is just providing some supporting evidence. Next, I tried to ask it a random question like, what is the best place to travel in summer? So because the chatbot is aware that it is fraud clarity specific assistant, so it tries to connect, like the question might be associated with some sort of fraud. So it tied it back to like, okay, we have a rule 12 that is associated with some sort of destination. And the answer that it generates, it is kind of trying to assess, like might be investigator is trying to figure out some summer or travel related fraudulent scenarios. So it generates an answer related to that. It's really vague answer, but it is not like generating a gibberish or something that is absolutely irrelevant. Um, yeah. Do I have another example? Yeah, similarly, I also tried asking it like, what do I make for dinner? And it also generated like, okay, fraudulent could be related to high-end restaurant meal. Again, this is not the best answer it could give. Um, but it is, I think it is not really telling me that I should eat a salad today, and it is not giving me a recipe for that. So I think still this is a big win, but there is a lot that we can work on and like tailor things to like make sure that nobody's misusing our platform. Yeah, I guess that is all from my side. I think I'll pass it on to Fanny for discussing the challenges and next steps.
Oh, okay. Can you go to the previous slide, please? Yeah. So again, like I mean, there is an analogy, right? Not every project is like a perfect project. It ends with, but we had our own challenges that we really had to overcome. Because like maybe because of some uncertain project scope and limited development and testing time. So Joshua, to answer your one of your question, right? So did we test it on the local cap on a Blackwell, and what was the max thing? I mean, we kind of like tested it to a local this particular chatbot, but we couldn't really add up the other parameters that we really wanted to test on. So like for example, we were able to use only like 8 rules out of those 31 33 rules that were given to us. So we could only like use only 8 rules and start testing on how this chatbot is really responding back to our questions. But also the other thing is like the the data from a data perspective, we had to like ingest it through a text one. So it's like the data is very local to whatever the chatbot that we are trying to test it out. But once you are able to connect to your streaming devices, I mean, your streaming data or to your static data that comes from different rules and everything, or whatever the documentations are getting updated, or the any transactions getting updated, the chatbot should be able to pick it up on the fly. But again, it depends on like how your backend systems are processing that particular data.
You have to stream down to the from the ingestion point. I got it. Thank you. That helps a lot.
And again, future enhancements. There are a lot of there's a lot of scope in this particular project, I would say, especially with the chatbot thing. It's no more than, I mean, maybe at phase 0 or 1, it's kind of a chatbot, but actually like it has. Once you go into the internals of this particular the architecture and things like that, we really understand. Hey, this is not really limiting to a generative AI solution or anything. It can be actually kind of expanded into kind of like an agentic AI kind of thing also. But again, that's a far too long. But at least for the future things, I would say like streamlining the pipelines would help in developing this chatbot and mature this chatbot to the next level, and ensure that strategic semantic chunking and metadata aware retrieval. So if you are able to add those two things to the future design, then probably I would say like, hey, we are about like 70 or 80% of we were able to get retrieve whatever the 70 to 80% of the outcome that we are expecting from this particular chatbot. So I will leave it there. But again, like there are so many things that went behind the scenes, because you really have to get that data, understand it, try to work on like get that chatbot working and things like that. So just kudos to my team. So any questions, we can take it up actually.
So while we wait
Yeah,
for questions, I just want to also thank Tazama for the opportunity given Delta Analytics and my team. The this project, even though the scoping was a bit of a problem, it really helped us to be more innovative and think up ways of whiling away the time and eventually coming up with this chatbots. Everyone here learned something, and so we are very grateful. We do hope, even though this is a POC, it would extend to something greater in the future. Thank you.
Yeah,
We have a
I'm
question.
trying to find if we have any questions that haven't been covered by answers in the chat yet. I think
Rediet had a question.
Yes, thank you. It was a great presentation. Thank you very much. I just have one question. I think on both presentations, it was mentioned on the first 15 rules are included, and then the second on the chat, 8 rules are included. Are there plans to include all rules in the future? Just wanted to check that.
Yes. So I'll pick that one up because I and I feel like I also have to comment about the scope because it came up twice. Right. So we were extremely grateful to be given this grant. And this grant arrived at a time that was very near perfect for us. So we were busy wrapping up the development for release 4, and there was an opportunity to add additional functionality to the system that we did not have the internal capacity to provide. And also, I think it was a fantastic opportunity to actually give real data scientists the opportunity to interact with our brand new solution. For us, that was a sort of a really great opportunity to get people's insight and their expertise and their first experience with our platform, which was really, really great. But because we had the opportunity for this grant, we ended up trying to put the kitchen sink, the fridge, the everything into the scope. So the Delta Analytics team very kindly helped us back from the brink and said, no, this is what we would be capable of delivering to give you something that adds real value. And both of those components were a really fantastic and succinct deliverable for us. The extension of the analytics to be able to do the drill downs into the rule space. We had presentations to prospective implementers long ago where they said they would really want to be able to do that kind of drill down. We have the demo user interface, and they said that kind of presentation information would be perfect for investigators as well. And the Delta Analytics team helped us to cross that bridge very, very neatly. So that was an amazing piece of work that helped us a lot. The proposal for the chatbot itself, that was an amazing and a welcome surprise for us because we did not anticipate that would even be possible here. And again, kudos to the Delta Analytics team for actually making that happen and delivering something that we can now use and take forward. The way that we approach the positioning of these deliverables is that because so much work went into just establishing the foundation, we consider this a minimum viable product that can now easily be extended with additional functionality, additional depth, additional data. So this is definitely not the end of this journey. We really appreciate the effort that went into creating reusable assets and assets that are easy to maintain and modify, which is exactly what we want as an open source product as well. The end product isn't the solution. The code is the solution for us. So all of the work that we see here today is something that we and our community can now build on and extend. And because it is modular, adding additional rules follows a pattern that is now well established by the Delta Analytics team as well. So that is something that we are looking forward to doing as a community and part of Tazama. We now have something that we can own wholesale and we can build on top of, which is really great.
Okay, got it. Thank you. Thank you.
Yeah, thank you very much, Justice. That was a good summary. And thank you for your support and your guidance in this project.
No, you're welcome, and thank you. Thank
Really,
you to
really
you and the
helpful.
team. Yeah, you have been so
I think
engaging
we've
in the
answered
channel as well.
So unless there's any more questions, thank you, everyone. Great presentations, great work. by the Delta teams, and thanks for your support, Tazama.
Thank you very, very much.
Thank you.
Hopefully we'll get to work together again in the future.
Thank you so much. It was a
Thank you.
it was a great opportunity.
Thanks,
Thank you,
everyone.
Justice. Thank you, Sandy.
Thanks,
Do you guys
everyone.
maybe want to, before you all go, if we could stop sharing and just put on your camera so that we can get a picture of everybody who participated in this project? Put yourselves on the camera. We're going to take a screenshot here. And just to say thank you very, very much to everyone. Michelle, I'm pretty sure that we can find a way to put this on LinkedIn as well.
Yes,
But
absolutely.
now's an opportunity to say cheese. So thank you very much, everybody.
I just came to work, so I don't know if I should be appearing on camera. This is Emmanuel on BCT. Thank you.
Thank you, Emmanuel. Thank you very much, everybody. And
Thank you, everyone.
good luck with your future endeavors.
Thank you.
Thank you
Great day
again.
ahead.
Bye-bye.
Thank you. Bye. Bye-bye. Bye.